This unit presents basic information about probability and statistics as used in the PMP exam. This unit covers probability and statistics as used in some of the processes of project management. The topic as a whole is much broader and deeper than you need to know for the exam, so don't let this topic intimidate you. A simple illustration of probability is given by the experiment of tossing a coin. The sample space consists of two possible outcomes, heads or tails. For a perfectly symmetrical coin, the likely probability would be 1/2 for heads, 1/2 for tails, or 50% each. The probability measure of an event is sometimes defined as the ratio of the number of outcomes. If weather records for July 1st over a period of 40 years show that the sun shone 32 out of 40 times on July 1st, then one might assign a probability measure of 32 out of 40, or 0.8, or 80%, to the event that the sun shines on July 1st. Compound events become a little more complicated. Compound events are situations in which two events occur, and we wish to know the probability associated with both happening, or either, or neither. The two events in this discussion are independent, that is, one does not affect the other. That is about the limit of our interest in probability. In situations where the probability will be determined by ratio, as we discussed earlier, we collect statistics, facts, about a population sample to allow us to determine those ratios. There is a whole mathematical science dealing with the collection of statistics concerning how one knows the validity of sample populations, how one knows the possible error in the numbers, etc. Again, this topic is not explored exhaustively here, nor on the test, but we do need some basics. So we collect a group of facts about a group. We are probably most familiar with the mean or average of those values. This gives us some idea of the midpoint or central tendency of the group. However, if we have no idea about how those values are spread out, we really don't have a very good picture of the group. We need to know how much the values vary. For this, we use standard deviation. The mean of a set of numbers is the sum of all the individual values divided by the number of values. This is the average you learned in grade school. The symbol mu is used to represent the average. In statistical process control, the mean is represented by the letter X with a line above and is called X bar. Two parameters are used to describe a distribution of values. A measure of central tendency, i.e. location/value of the center, and a measure of scatter, i.e. how scattered the values are about the mean. The standard deviation is the usual measure of scatter and is a possible source of several exam questions. Standard deviation is represented by the Greek letter sigma. Yes, that is the same sigma as 6 sigma. One type of distribution is the normal distribution. This is the familiar bell-shaped curve that is symmetrical and extends to infinity in both directions. Obviously, no distribution of actual values extends to infinity, but this is useful as an approximation of real-world situations. The symmetrical nature of the distribution means that we can talk about values on either side of the mean with equal accuracy. A useful characteristic of the normal distribution is that 68% of the observations fall within one standard deviation of the mean, 95% fall within 2 standard deviations, and 99% fall within 3 standard deviations. Learn these percentages for the test. By the way, 6 sigma yields 99.9997%. This means that a distribution of values of the outcome of a 6 sigma process will be 99.9997% good. 3 defects in a million. Pretty good. These are the formulas for these items. If you are formula-oriented, learn these. If you understand words better, refer back to our definition of each. I like words myself. The mean is calculated by summing, that's a capital sigma, all the values, x, and dividing by the number of values, n. The standard deviation is calculated by subtracting the value for each data point, x sub j, from the mean, square the difference, which gets rid of the negative value on half of the numbers. Then we add up, sum the squared values, dividing by the number of values to get the mean or average of the squared values. This mean is known as the variance. Then take the square root of the variance to get the standard deviation. A normal distribution is the most commonly used distribution and is referred to as the bell curve. It models many different kinds of natural random phenomena and approximates processes that usually occur in the production of goods and services. Note that the percentages are the same on each side of the mean, reflecting the symmetrical nature of the distribution. A key useful feature is that 1, 2, and 3 standard deviations will cover the listed percentage of the outcomes, as noted before.